I'm Nidhi Kumar and you're watching Science Time, a show that brings to you the best that science offers, from exciting developments in science and technology to futuristic solutions. Scientists made a Möbius strip out of tiny carbon nanobelt. Zoological Survey of India scientists discover new macaque species in Arunachal Pradesh. New artificial enzyme shows potential for new renewable energy source. And let's take you to story number 1. From cylindrical nanotubes to the hollow spheres known as buckyballs, carbon is famous for forming tiny complex nanostructures. Scientists have added a new geometry to the list, a twisted strip called a Möbius carbon nanobelt. Möbius strips are twisted bands that are famous in mathematics for their weird properties. A rubber band, for example, has an inside and an outside. But if you cut the rubber band crosswise, twist one and glue it back together, you get a Möbius strip, which has only one face. In 2017, researchers created carbon nanobelts, thin loops of carbon that are like tiny slices of carbon nanotubes. That feat suggested it might be possible to create a nanobelt with a twist, a Möbius carbon nanobelt. To make the itsy-bitsy twisty carbon, the team of researchers led by chemist Yasutomo Segawa of the Institute for Molecular Science in Okazaki, Japan, stitched together individual smaller molecules using a series of 14 chemical reactions. The research is reported on May 19th in Nature Synthesis. While carbon nanotubes can be used to make new types of computer chips and added to textiles to create fabric with unusual properties, scientists don't yet know of any practical applications for the twisty nanobelts. And with that, let's take a look at story number 2. And scientists of the Zoological Survey of India have discovered a new macaque species in Arunachal Pradesh. The new species, named Sela macaque, was found in western and central parts of the state. ZSI Director Dhriti Banerjee said this. The new species is separated from the Arunachal macaque of the Tawang district by Sela Pass, Banerjee said. The Sela macaque is genetically closer to the Arunachal macaque, and both species have many similar physical characteristics such as heavy build and long dorsal body hair. However, there are also some distinct morphological characteristics. The Arunachal macaque has a dark face and dark brown color coat, while the Sela macaque has a pale face and brown color coat. The study on the new macaque species has been published in the Molecular Phylogenetics and Evolution journal. And with that, let's take a look at story number 3. Well, a new artificial enzyme has demonstrated it can chew through lignin, the tough polymer that helps woody plants maintain their structure. Reporting in the journal Nature Communication, a team of researchers from Washington State University and the Department of Energy's Pacific Northwest National Laboratory demonstrated that their artificial enzyme succeeded in digesting lignin, which has stubbornly resisted previous attempts to develop it into an economically useful energy source. Lignin, which is the second most abundant renewable carbon source on Earth, mostly goes to waste as a fuel source. When wood is burned for cooking, lignin byproducts help impart that smoky flavor to foods. But burning releases all that carbon into the atmosphere instead of capturing it for other uses. Lignin is present in all vascular plants where it forms cell walls and provides plants with rigidity. And chemists have tried and failed for more than a century to make valuable products from lignin. In the current study, the researchers replaced the peptides that surround the active site of natural enzymes with protein-like molecules called peptoids. Peptoids were first developed in the 1990s to mimic the function of proteins. They have several unique features, including high stability that allows scientists to address the deficiencies of natural enzymes. In this case, they offer a high density of active sites, which is impossible to obtain with a natural enzyme. As expected, these artificial enzymes are also much more stable and robust than the natural versions, so they can work at temperatures up to 60 degrees Celsius, a temperature that would destroy a natural enzyme. And with this, we come to the end of this edition of Science Time. We'll be back with more exciting stories from the world of science next week. Until then, stay tuned to India Science. Namaskar.